Hello everyone, my name is Syed Afrid from Section D of AIML and my ID is 24951 866N9 and the subject is Essential of Problem Solving and my topics is GDUI, Guided Diffusion Model for Unlabeled Images. So I want to explain in detail of guided diffusion, a deep dive into models for unlabeled images. So first of all, I want to give the introduction of this topic and this method. So this presentation explores guided diffusion models focusing on applications involving unlabeled images. We will cover model architecture, training processes, and future directions in this innovative field. So first of all, we will see what is overview of the given topic and what are the major efforts to update this level into this topic. What is guided diffusion? Guided diffusion is a generative model technique that leverages the diffusion process. It iteratively transforms noise to generate data samples guided by specific objectives or conditions. And applications of guided diffusion models. Guided diffusion models have diverse applications, including images generation, image complication, and style transfer, being invaluable in both research and industry. Important of unlabeled images and how it is important and how it's helpful in our future generation. So unlabeled images are crucial for training models in setting where labeled data is scarce. Guided diffusion models can effectively learn from these unstructured data sets. And from this, the overview is get completed and we will go to the second topic, that is model architecture. So now it's time for model architecture and how it is performed and how it's designed. So key components. So the key components of a guided diffusion model include the diffusion process, conditioning, conditioning input, and loss functions, which collectively optimize the model's output. Next, diffusion process. The process of this diffusion. So we will see now. The diffusion process is a series of transformation that convert noise into coherent data. This process often involves multiple steps to achieve a refined output. So guidance techniques we will see in the next slide. So now the guidance techniques. Guidance techniques enhance the diffusion process, often using additional information or used to steer the generation towards the desired outcome. Next, we will see training process and how we are going to use it in our daily base lives and mobile applications. So data preparations. Data preparation is a critical step in training guided diffusion models. This involves collecting a diverse and representative set of unlabeled images and pre-processing them to ensure consistency and augmenting the dataset to improve model robustness. So we'll see training strategies. Effective training strategies for guided diffusion models include different approaches such as supervised, semi-supervised, and unsupervised learning. Each strategy takes advantage of availably available data differently and influences the model's performance. So next we will see the performance matrices. Performance metrics are essential for evaluating the effectiveness of guided diffusion models. Common matrix includes inception score, Fetched inception distance (FID), and perceptual similarity measures that assesses the quality of generated outputs. And we have completed the major topics, major tops and side headings of this topic, and we will see use cases. And performance is over, now use cases. And the four use cases. So here image generation and how it's image generated in GDUI. One primary use case of guided diffusion models is in image generation, creating high quality and realistic images from random noise, enabling applications in art and design. And this all comes under image enhancement, and we will see many AI images are created in our daily life in mobiles, and we will seeing every day. So we will go further and deep into this topic, that is image enhancement. Guided diffusion models can also be utilized from or for image enhancement tasks, such as improving resolution, polarization, and detail recovery, resulting in more visually appealing outputs. So, how it is useful in our real world applications, we will see in the next slide. That is real world applications. In real world scenarios, guided diffusion models find applications in various fields, including fashion design, film production, and scientific research, demonstrating their versatility or versatility. And we will see future directions. And from this, the topic is fully concluded: an enhancement of process and performing and creating an AI, and the community, the code all is completed, and we will see how it's useful in our future generation, how it will become update. So now 5, topic number 5, that is future directions. The research trends. Emerging research trends in guided diffusion models focusing on improving efficiency, reducing computational costs, and enhancing generative compatibilities to expand their applications significantly. Now the potential improvement and how it will be improvement from the potential we will see now. That is potential improvements for guided diffusion, that is GDUI. Models include refining algorithms, better training techniques, and integrating cross-domain capabilities to enhance overall performance and applicability. So we will see in this guided diffusion models including refined algorithms and better training techniques and integration cross-domain capabilities to enhance overall performance and applicability. So the performance and visibility of the given images depends on potentially improvements. So it must be very improved, and it used to be very realistic to get our concentration towards the GDUI. So next one, challenges ahead. So how it throws the challenges to us for our future and development paths. So now, despite the performing future, challenges such as the needed for large datasets, we really need the datasets, model interpretability, and ethical implications in AI remain critical issue to address. So these are the challenges which it throws to us, that are needed for large data sets, model interpretability, and ethical applications in AI remain critical issue to address. So the last one we will see conclusion, and I want to give the best conclusion for this topic. So that is, in summary, guided diffusion models representing a significant advancement in image processing with vast potential applications. Understanding their architecture, training, and future directions will shape their effective usage in various fields. So this is how the topic concludes. So I will thankful you all who gave this wonderful opportunity to explain the GDUI and images, and this image will get more effective and concentration of us to for understanding levels, and this helps you in get more active listening and active watching of these topics. So we'll get knowledge best from the normal to this AI technique. So thank you.